What if one single test could detect literally every infectious threat?
You mean bacteria, fungi, and viruses?
Everything. All of it. In a critically ill ICU patient. And this is the key part. Deliver results the very same day.
That would be a complete game changer for critical care.
Exactly. And if that sounds like the key to precision medicine, well, you'll be very interested in the groundbreaking results of a recent publication from the Lancet. So today, let's dive into this rapid pan-microbial service.
This is so critical because our current diagnostic toolbox often fails our sickest patients.
Fails them how?
Well, the traditional culture-based methods are just agonizingly slow. We're talking days. And they often miss fastidious organisms.
Yeah.
The really hard to grow microbes.
Right, or anything that's already been hit with antibiotics.
Precisely. The treatment itself can hide the cause.
And I imagine even the more modern tools like targeted PCR panels have their own issues, right? You're still kind of flying blind.
You are. Those panels only look for threats you've already decided to look for. So they constantly miss crucial co-infections, a lot of fungal pathogens, and any unexpected or emerging viruses.
So all these blind spots, they can delay or even misdirect therapy.
Completely misdirect it. But this new prospective study out of Guy's and St. Thomas's hospitals, it introduces a really profound shift. A unified pan-microbial metagenomic workflow.
Okay, unified, meaning it covers that entire spectrum we mentioned.
Hmm.
Bacteria, fungi, and viruses, all in one go.
Yes, exactly. It's one assay from one respiratory sample, simultaneously detecting all three kingdoms of microbes.
Wow, and they actually achieved same-day results.
They did, with preliminary positive findings available in just 2 hours of sequencing starting.
So how did they pull that off? I mean, to get that speed and breadth, there must be a big technical hurdle to overcome.
There is, a huge one. When you sequence a respiratory sample, the vast majority of the DNA you get back is human. It's just noise obscuring the signal.
So you have to somehow strip away all that human noise to see the microbial signal clearly.
Exactly. And the key innovation here involved mechanical lysis, basically, breaking open all the cells, followed by a really targeted treatment of the samples.
A treatment.
Yes, they use a salt-active, non-specific nucleus from a company called Arctic. It's used specifically for host DNA depletion.
So just chews up the human DNA, leaving the microbial stuff behind.
That's the idea. This selective removal step is essential before you extract the nucleic acids. It makes sure the microbial DNA and RNA you want to see are concentrated and clear.
And for a patient in the ICU, every single hour counts. How did that technical step translate into real-world speed?
That cleanup step is really the engine behind the speed. With it, pathogen detection can start in as little as 30 minutes of sequencing.
30 minutes.
And crucially, the final comprehensive report was delivered within 24 hours, often before 5 p.m. on the very same day the sample was taken.
So we're talking about sub-7-hour sample to report times. That is just unprecedented for this kind of pan-microbial analysis.
It is, and the performance metrics really validated that speed. They reported very high sensitivity in lower respiratory tract samples, around 97% for bacteria, and about 89% for both fungi and viruses.
And the specificity.
Consistently above 98%. But the real proof for me is that the assay found 42 additional pathogens that routine diagnostics had completely missed.
42. Across what percentage of patients?
Across 30% of the tested samples.
Wow. Okay, so that leads to the big question. What was the actual clinical impact? Did it change what doctors did?
It absolutely did. Antimicrobial therapy was changed in 28% of patients.
And was that mostly scaling up or scaling down?
Both. About 21% were de-escalated, which is great for stewardship, and 7% were escalated. And that was often because the test detected antimicrobial resistance genes like ESBLs.
Which is a critical piece of information.
Life-saving information. And what's really novel is that the test also helped guide immunomodulatory therapy in 20% of patients, linking it to treating inflammatory lung processes.
And the public health implications must be huge, too.
Oh, enormous. They detected Mycobacterium tuberculosis 5 weeks before culture confirmed it. They also found things like HIV-1 and the measles virus.
And all of that performance really hinges on that foundational technical step, doesn't it?
It all comes back to that. It's worth reinforcing that Arctic's salt-active, non-specific nucleus is what enabled that selective host DNA depletion. That process is what enhances the microbial read depth, the clarity and volume of microbial genetic material. And that's the scientific reason they achieved such high speed and sensitivity across all three kingdoms at once.
So when you put it all together, what this system really provides is personalized patient treatment and population surveillance, all in one test and at the speed of ICU decision-making.
Exactly.
So it leaves us with a pretty big question, I think. With results this fast and this comprehensive, could pan-microbial metagenomics become the new frontline standard of care for severe respiratory failure? I mean, this study really forces you to consider it.